Okay guys, what we're going to do now is we're going to go ahead and go into our project book, and we're going to create a digital hourglass that's going to basically take into account how long we've been pressing down the button. Alright, so shouldn't take too long. Let's go ahead and make this circuit first. So you see we have a bunch of LEDs, and each LED is connected to, if we zoom in here, we have pins 2 to pins 8. And as you know, these are 220s. They can be a little higher, actually. We've used higher. It doesn't matter. And then we have a tilt switch. You can use a button or tilt. It doesn't really matter. So let's go ahead and go over to Tinkercad, and let's go ahead and do a breadboard. All right. And let's do an Arduino. Okay. We can rotate this if you want, make it a little easier for ourselves. Let's do LEDs. Don't want to do that. Okay. I'm just going to go ahead and hit Control C, Control V. 2, 3, 4, 5, 6, 7. You can do as many as you want. And then resistor. Okay. You want here 220. Ohm, not kilo ohm. Okay. 1, 2, 3, 4, 5, 6, 7, and we'll do one resistor at let's see, 10 kilo ohm. Okay, 10K. So one 10K resistor. All right. We'll put this one over here, and then we need a tilt switch. You know what, let's just use a button, just make our lives easy, because it doesn't look like they have it. That'll work. Alrighty. Let's go ahead and start connecting everything. So let's power up our breadboard. If we look here, alright, so the switch is going to go to 8. So if we look up here, you notice that the switch here goes to 8. And then the LEDs start at 2 and they go to 7. Okay. We got this. So let's go ahead and take our 10K resistor, rotate it, put it on the board. Remember, this is a pull-up resistor, so we're going to be pulling up the signal. Actually, that's 8. It's supposed to be 8. Alright. Okay, cool. Now take these guys, just rotate them. Remember, that's our anode, so that's the positive one, and the cathode is the negative one. So we're just going to go ahead and rotate this. Just move it out a little bit. Okay, let's put it on the on the negative side. And the positive side will run over to where we need to run stuff over to. Alright. This might be a little bit messy. Doesn't matter. Okay, so I'm going to take this and hit Control C, Control V. Let's see if I can do that. Yep. Do this because this will make your life way faster, okay? And then this one, let's run this over to 6. You guys could forward through the video if you want. I'm going to go ahead and do this kind of one at a time, but see if I could do this. Nope. All right. All right. One, two, three, four, 5, 6, 7. Okay. I guess we could get rid of all this junk. All right. Now we just have to wire it. All right. My wiring is going to get kind of sloppy. Sorry. One, two, three, 4, 5, 6. Okay, so it's 6. That's all we're gonna do. We'll get rid of this last one. Kind of sloppy. I probably could have ran this around the board. Doesn't matter. Okay, so let's go ahead and power up our board. All right, that's it. The only thing we have to do now is wire this part of our switch. Okay, so this is, again, a pull-up resistor. It's going to be pulling up positive. Remember, that's how pull-up resistors work. Pull down would be the one in the negative. You actually don't need this. You could actually just get rid of this. Just make your life easy. Get rid of that. And then we could just put input pull up there. All right, so let's go ahead and start coding this, and we'll code all this stuff. Let's go ahead and do it. All right, let's go to our, we don't want blocks, we want text. Okay, so let's go ahead and do our coding. So what we're going to do here is we're going to start off with our main stuff here. So we're going to say const int button pin is going to equal 8. So this is set up the button pin there. Then we'll say long. We can do unsigned long previous time equals 0. So an unsigned long is just a large integer. Unsigned means it won't be negative. So our switch state that we usually do Alright, so that's that. So we're going to start off our LED at 2. That'll come into play later. And now we're going to say long interval will equal, we're just going to do every second. They have 60,000. We're not going to do that because that would be really hard to test. Okay, so let's go ahead and set up our main code here. This is, what I'm going to show you now is called the for loop. So this means for int x equals 2, so you make a variable called x, make it equal to 2. While x is less than 8, x plus plus means add 1 to x. And the reason why we're doing this is we're going to start off, if you look here, we're going to start off at 2, which is where this LED is. And then we're going to work our way to 7, because less than 8 is 7, where this LED is. And what are we going to do with this? We're going to set up our pin modes. You don't have to do this. Pin mode X, that means that's the counter. So in this case, we'll start off at 2, and we're going to make it output. Okay? So that'll be that. That's a really fast way of doing like pin mode 2, comma output. Pin mode 3, comma output. pin mode 4, comma output. That's just a faster way of doing that. Otherwise, if you didn't do this, you'd have to do something like this. Like that. So on and so forth. So that makes it faster, so you don't have to do all that. All right. Now we'll say pin mode button pin, and we want input pull up. So it'll always pull up. It'll be 1 if it's not clicked, and it'll be 0 if it's clicked. So this reverses. So remember, 0 equals clicked, 1 equals not clicked. Okay? All right, so let's move on with our code. So the first thing we're going to do is, let's see, close that, close that. Now that we're done with our setup function, we're going to start our main function. All right. So here we go. Okay. So let's get back to our coding. Get rid of that. All right. So let's go ahead and go on to our main parts here, which are our void loop. So let's do it. So we're going to say these unsigned variables you really don't need. You probably could make those ints, it'll work. So what this does, unsigned int current time equals millis, that gets the current time of your program, okay? Like the current time it's running. So if you just started your program, millis will start out at 0. If you've been running your program for a minute or a second, millis will be 1,000. A minute, it'll be 60,000, like that, okay? Or 6,000, rather. Current time minus previous time is greater than interval. Let's look what all this means. If current time, so remember up here, we had previous time is 0 and current time is millis. So if current time, so you're going to get your current time minus your previous time. In our case, it'll be 0. So we're going to hold down our button, and is the current time less than the previous? If the current time minus previous time is greater than the interval, and what's our interval? Our interval is 1,000 milliseconds. So has 1 second passed since we've been holding the button? Yes? Okay, good. You make your previous time equal to your current time. So what that does is reset it for the next second. That's what's going on there. So now we're going to go ahead and do this. This is a little weird. Let me explain what's going on here. By the way, this means LED equals LED plus 1. So let's look at what this means. Digital write LED high. Okay, LED is starting off at 2. So that means basically port 2. Port 2 is here, or pin 2. So you're going to say digital write pin 2 high. Okay, now you're going to say LED plus plus. So if this interval was true, you're going to say, okay, now light up this one. All right, great. So that's that. Now we're going to say if LED is equal to 7, that means we have reached the ending. You could do something like this. Let's see here. Let's try to get this formatted a little bit nicer for you. Print x equals 2. Okay. So what you're doing here, if LED is 7, let's do this. Instead of pin mode, we're going to do digital write X, comma, low. And then what's cool is we could put a little delay in here. Let's do a delay of like 100 mils. So we could see it go, like, disappear. So after 7 seconds goes, we turn them all off. Okay? All right. And okay, I'm actually going to modify the code in the book a little. Let's look at the code. So this code in the book is a little different. It's doing the digital write with the switch, so I don't want to do that. Actually, since we're not using a tilt switch, I'm going to do this a little different. So let's do, all this code is good, right? All this code is good. Let's close this off. So this, let's say this one gets closed off by this, this by this, this by this. Okay, now we only want to do all this code if this. If, we'll say int button state equals digital read. Where are we? Button pin. Okay. And we're going to say if I'm going to try to make this a little bigger here. There we go. I'm just doing this by hitting tab. If button pin is equal to 0. That means it's pressed. All right. So we're only going to do this if button pin is equal to 0. That's it. So what's happening is, so if the button is pressed, if the current time minus the previous time is greater than the interval, previous time is current time, so you're resetting, this is resetting the timer. You are lighting up the next LED. Then you're going to the, you're adding 1 to the LED, so you're hopping over to the next pin. And then what we'll do is, if LED equals 7, we turn everything off. So what we do is this. Excuse me. Okay. So what happens here is, if all our LEDs are lit, we are going to turn off all the LEDs. Now, the one thing we haven't done yet is this. So down here we have to say LED equals 0. So reset, actually not 0, 2. So here you have to reset the LED back to, back to pin 2. All right? And let's see, anything else? We have to close this function. So let's look at make sure our braces are good. We'll start out, this is the way I like to do it. This closes this. This closes this. This closes this. This closes this. And now this will close this one up here. Good. And is there anything we're forgetting? I don't think so. There's one case where we have to code, actually. So let's say we held it down for 2 seconds, and then we let it go. When we let it go, we should probably turn everything off. You don't have to, but you might want to. So let's see how this works. see here. It says digital. Oh, I misspelled digital read. D-I-G-I-T-A-L. All right. All right. So let's hold it down. And we don't get anything. Let's do something really quick. Let's say in the setup, serial.begin, 9600. And now here we'll do serial.print. Button state. All right. And let's look at our serial monitor. Okay. Let's stop. Okay, what we need to do is this. Let's see. Do we need to do this? Let's see. Let's pause this a second. All right, so I'll show you what my mistake was. It was here. It was if button state, you had button pin, so that was a typo. Also, this button was in the wrong way. I accidentally had my button this way. It has to be this way. So it has to be the way that, terminal 1A and terminal 2A are being connected, not terminal 1A and 1B. That won't work. It has to be 1A and 2A or 1B and 2B. So that was a mistake. So now if you run it, it's good. There's one thing you might want to do here. You might want to say delay 1000, and then here put delay 200. So now let's start the simulation. And then basically this is like a timer of how long we've had the button down. You know, in the real world, this will only last a second. On here, it's a little bit slower. Okay. So you'll see how this works. Now, there's one mistake here as well. You could say, you'll notice that this one goes to 7. So if it equals 7, we still want to light up the LED. Okay, so here what's happening is it's not lighting up the LED. So what you might want to do is do this. Copy this. Put this here and paste it. Now if we start the simulation, watch what will happen. So you're basically just seeing how I would go about debugging if I was making some errors in my code. So this is kind of like a live debugging session. So if you watch, just give it a second. And they go away. Okay, so even if I let go, it's not going to do anything, right? It'll just sit there. Now if I click it again, now you could break it if you were, no, you can actually. You have to hold it. So I let go, I hold it, and there you go. You could, let's do one adjustment here. Let's do something cool, where if we let go, let's turn all the lights off. So let's do it. So we'll say, if button state, so that's ending here. We'll say this. If button state equals 1, that means it's not being pressed, and LED does not equal 2. So that means some of the LEDs are lit. Now let's do this. All right, and we'll paste it here. So let's take a look what's going on. So what we're going to do here is this. So if button state is equal to 1, that means it's not being pressed, and the LED doesn't equal 2. So that means that something, what do you call it? Something, some of the LEDs are lit. So we're going to start off. We don't know which ones are lit, but we're just going to go through and turn them off. So let's try this. So we'll light up a few of them so you can see what this does. Okay, and I'll let go after the fourth one. See? Let's try it again. Now, you see there was a bug there. Watch this bug. See? It's not starting back at where the LED should start at. So watch this. Let's give it a second so you can see the error. All right, let me let go. So now these were lit. It's going to start here now, watch. So let's go ahead and reset the LED as well. LED equals 2. So this will reset the LED back to pin 2. So let's try this now. So that's another bug. And that happens when you code. So what you have to do is you have to kind of just debug it and, see what the result is. Maybe I didn't think of that possibility that it would get screwed up. So we'll just wait a second. Let's let go. See, that's the behavior we want. So now we basically have a digital hourglass of how long we've held the button down. That's the project. I hope this code makes sense. The only part of this code that isn't really necessary is this. Like I said before, you could have just done the pin modes on the ports individually. But that's it. And I added this in because I thought it was cool. Really, it's not necessary. So again, what this does, this whole thing of code, is saying if button state equals 1. So if we didn't press it and our LED doesn't equal 1, so that means one of the other LEDs, some of the LEDs are already lit. We're going to go through in this loop our LED array, and we're going to turn off the LEDs that are on, and we're going to reset this. Remember, if we didn't reset this, let's say it was up to here, it was lit. It'll go like off, 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 and it'll start here on. So that's what that does. So I hope you understand this code, kind of get how the for loop works. And this week I'm just going to make 2 exercises that are pretty simple. I'm just going to ask you to make a buzzer when it reaches the end. And I'll have one other thing that I haven't thought of yet. You will see it in the worksheet that I'll type up. I hope you enjoyed this tutorial and you learned about for loops and review timers.